questions first. Have you ever made changes to a file or code by mistake which you wanted to revert to later? Have you ever lost a code or file? Do you have a backup of the code you write and change every day? Did you ever have to maintain multiple versions of a code or a file and analyze the differences between them? Did you ever have to share your code or let other people work on it? Do you ever track the work being done in detail? Do you need to experiment with your codes without messing up the current work? So have you faced one or more of these challenges? If the answer is yes, you need a version control system. The most popular of all is Git. Git is the most widely used open source distributed version control system in the world today. It can handle small to large projects efficiently. Most of the existing version control systems have a centralized repository, which makes collaboration a tough nut to crack. Git offers a local and remote repository with an option to sync the changes simply by executing a few commands. Also, Git is a free and easy-to-learn open-source project. It outclasses SCM tools such as CVS, Perforce, Subversion, and ClearCase, with features such as branching, merging, rebasing, cloning, and multiple workflows. A number of industries such as Google, Microsoft, Facebook, Netflix, and even NASA are the users of Git. Git has local and web versions to facilitate easy and effective collaboration. So if you are familiar with the basics of command line and collaboration is part of your daily routine, or you are not sure how to control the version of your files or codes, this course is ideal for you. With over 4 hours of e-learning content, interactive demos, supporting guides, cheat sheets, assignments, and projects to help you understand and practice the operations you can perform in Git, you can solve all your versioning problems yourself. Here's what Simplilearn's Git course will enable you to do. Explain distributed version control system and its features. Set up Git in your system. List the 3-stage workflow in Git. Create branches and track files. Create a repository in Git and GitHub. Describe merging, cloning, rebasing, among others. You will receive complete support from Simplilearn throughout the course. On successful completion of the course, you will receive a certificate. To be eligible for this certificate, you'll need to complete the project. Have questions? Submit them at help and support on www.simplilearn.com or talk directly to our support staff using the Simply Talk and live chat options. Go ahead and begin the Git course. Happy learning! Hello and welcome to the Git course offered by Simplilearn. This lesson introduces you to Git and helps you get started with it. In this lesson, you'll understand the basics of Git with examples and learn the steps to install and configure it on your system. Before you learn what Git is, let us first understand why you need Git. Let us begin our journey with an example to help you understand better. Welcome to NASA's Ames Research Center. Ames is home to various NASA projects covering areas of expertise such as nanotechnology, fundamental space biology, supercomputing, and thermal protection systems. NextGen is an Ames project comprising 150 software developers and aeronautical engineers. This project aims to enable the National Air Transportation System, designed to ensure maximum safety, reliability, and efficiency. The core development team works toward the successful execution of this mission. What could be the possible challenges of this mission within the development team? How to develop software collaboratively and securely while adhering to NASA-approved processes and guidelines. How to maintain and control the version of the codes. How to create and maintain remote repositories. How to branch and merge the codes within the main repository. How to maintain a local repository with the same features to protect the server data, and many more. Many projects face similar challenges. Now, how does NextGen resolve them? NextGen uses Git. Let's find out how Git resolves each of the challenges. So, what does Git do? It provides a flexible environment to work collaboratively and securely. It has a version control system that allows multiple users to modify the same file, to record and track changes, to revert to the earlier versions, to compare multiple versions of a file, to manage conflicts and merge files. It allows users to create and manage remote repositories. It facilitates the branching and merging of files within the main repository. It allows every user to have a copy of the project files locally, thus making the files in the server secure. All these features of Git make NASA one of its biggest users. This brings us to a very interesting question: why choose Git over other version control systems? Existing version control systems have a centralized architecture. This means there is a single central server that stores all the project files. Changes cannot be done offline. Users can retrieve files into their workspaces, make necessary changes, and commit them to the central server. The data can be pulled by the next user only when they are online. All changes made in central server. Connecting to the central server is necessary to make any edits. This means there is no room for error. With all these challenges, existing version control systems are difficult to work with. Git is a one-stop solution to all these limitations. Let's now understand what Git is. Git is a version control system. It's a distributed revision control system aimed at speed, data integrity, and security. Git was originally developed by Linus Torvalds in 2005, the creator of the Linux kernel. It was designed to overcome the limitations of other version control systems. Let's now quickly install and configure Git to explore all its features. Now that you are familiar with the capabilities of Git as an effective version control system, let's work on installing and configuring Git.
Installing Git on Windows.
First, we'll install Git on your Windows system. Follow the stepwise tutorial for guidance on the setup. You can also download the installation guide from your LMS. Download the installer from http://git-scm.com. After the download is complete, click the .exe file. The Open File window opens. Click Next. Select the folder where you want to install Git. Click Next. Keep the default elements checked and click Next. Click Next. Select Use Git from the Windows command prompt. Click Next. Select Checkout Windows Style Commit Unix Style Line Endings. Click Next. Select Use min-tty, the default terminal of MSYS2. Click Next. Keep the boxes checked. Click Install. Wait for the install to finish. Select Launch Git Bash. Click Finish. Open the Git CMD. The Git console opens. Execute Git version to verify your installation. This should output the appropriate Git version. You have successfully installed Git. Git can be installed on a Mac system using the following methods. Method 1. Download Git from http://git-scm.com/downloads. Execute the installer. Select default settings, which are all the windows that appear during the installation. Execute Git version to verify your installation. This should output the appropriate Git version. Method 2. Use the package manager homebrew at brew.sh. Brew install Git version. Git can be installed on Linux using the steps shown. Use the preferred package manager on your Linux distribution. On Debian-based distribution like Ubuntu, apt-get install Git version. On Fedora, yum install Git up to Fedora 21. dfn install Git, Fedora 22 and later, Git version. Now that you have learned how to install Git, the next step is to configure it to execute commands. There are 3 levels of configuration in Git. System level. System level is the topmost level. It's applicable to everyone who uses the system in which Git is installed. The settings are defined using git config system, which is then saved in the /etc/gitconfig file. Global level. This is the next level after system. It refers to user settings for all repositories. The settings are defined using git config global and saved in git config. Local level. This is the last level and refers to the user at a repository level. The settings are defined using git config local and saved in git/config. All the files follow the same pattern independent of the level it is defined on. Note, local overrides global and global overrides system level. For any commits within a Git repository, the following setting needs to be configured, failing which the git commit command will throw a warning. User.name, user.email. This demo will discuss the methods to configure Git. Let's start by answering a simple question. What is the minimum config to configure Git? You can derive the answer to this by invoking the git commit method in the Git console. Git indicates 2 missing configurations, user.name and user.email, that need to be defined at the global level. Let's define them. Execute. Git config. Define a level user.name. Your name to define the user. Execute git config, define a level to define the user.email. The input is accepted by Git as shown. User.name and user.email are mainly configured to associate commit actions to a particular person. In addition to these, there are several other configurations that should be made. The next step is to configure Git at a global level and choose a color of the UI to define the configuration of the editor. Git config global core.editor C:/program files /sublime text 3 /sublime text.exe. Now that you have defined configurations, you should know how to extract and view the ones made. For information relating to the number of configurations, execute git-config list. This enables you to view the details of core editor, user.name, user.email, and color.ui, and access the effective configurations. To check the configuration level, execute git-config global user.name. This shows you the configuration output. If we change the level to system, we find no configuration. This means there is no configuration defined for the system level. These configurations are stored within a particular file in the user directory at git-config. This defines all global configurations. Now, let's summarize what you have learned so far. Git is a version control system. It has a distributed architecture. It provides a flexible environment to work collaboratively and securely. You can create and manage remote repositories using Git. Git facilitates the branching and merging of files within the main repository. Git allows every user to have a copy of the project files locally, thus making the files in the server secure. There are 3 levels of configuration in Git: system level, global level, and local level. User settings in Git are mainly defined at global level because they correspond to user level settings for all repositories. In the next lesson, we'll learn about the steps to create a repository in Git, the Git workflow, and tracking and committing in Git. Hello, and welcome to the second lesson of the Git course offered by Simplilearn. This lesson introduces you to the operations you can perform in Git. In this lesson, you'll learn to create a Git repository, understand the Git workflow, and perform various operations, such as tracking, reverting, deleting, ignoring, and renaming files in Git. Let's create a repository in Git. Create an empty directory. Command mkdir directory name. Convert the existing directory into a repository and manage its contents in the version control system. Command git init. Run git status. Command git status. This takes you to the branch master with no files to commit. Note, git init command creates a hidden directory that stores all the metadata required for it to function. Let's now understand the process of creating a repository in Git through a demonstration. Let's start by creating a directory. Execute mkdir myproject_dir. Next, create a repository using the command git init. This initializes an empty Git repository as shown, and displays the hidden directory, Git. Initially, the main directory is empty. Let's check the contents of the hidden directory. Execute ls-la. This shows the existence of a Git directory, where all the Git metadata is stored. To check the status of the repository that was just created, execute git status command. Git status shows that you are in a branch master and there are no files to commit. The branch master is created by default. So, to create a Git repository, you need to create a directory and convert it to a repository. Can these two actions be clubbed? Yes. Execute git init directory name. This helps to create and initialize a directory at the same time. Let's now check the contents of the file. As you see here, a repository in Git has been successfully created. Now that you have learned how to create a repository in Git, you should learn about the Git workflow to understand how to commit the files in the repository. Git maintains 3 snapshots of a file, which are maintained in separate directories. The first directory is called the working directory. It refers to the directory where the command git init was executed. When a new file is added to this directory, the file is not tracked by Git. For Git to track this file, you would need to stage it. This is done by the git add command. Once a file is staged, it is stored in Git index file called the staging area or index. Later, this file is committed to the local repository using the git commit command. Let's now discuss the stages of workflow in detail. In order to move the files from the working directory to the staging area, drop a file into the directory. The file is untracked at this stage. Add the file in the staging area by using the command git add. Once the file is added, it's tracked and ready to commit. Execute the git commit command to commit the file into the local repository. The working directory is now clean. That is, the local repository is in sync with the latest changes in the working repository. Note, while committing, it is important to add a message string using the -m flag. If missed, a default editor opens asking for comments. Let's now understand how Git manages subsequent changes to a file and how you view them. To modify a file in Git, update the file, add it to the staging area, and commit the changes to the repository. Execute git log to view all the changes in a file in reverse chronological order. This shows an exhaustive list of all the commands made with a unique commit ID, author, date, and the commit message. Note, to restrict the output to one line, execute git log one-liner. This will display the information in a single line. Let's understand the execution of the Git workflow through a demo. You are in a particular directory in the branch manager, and there are no files to commit. The working directory is empty, which means your first step is to create a file before you add it to the staging area. Execute touchindex.html. Now that you have created a file into the working directory, the next step is to check the Git status. Git labels the created file as untracked, which means it's not being tracked currently. To track this file, you need to move it to the staging area, which can be done using the git add command. Execute git add. Next, execute git status to check if the file is being added. The output indicates the addition of a new file, which is now tracked. This means the file index.html is moved from the working directory to the staging area. The next step is to commit the changes. So, execute git commit -m commit message. After Git confirms the commit and indicates the change, execute git status to ensure that the file has moved from the staging area to the local repository. Now that the file has been created, added, and committed in Git, let's see how modifications and viewing the file status work. Let's update the HTML file. Execute echo HTML HTML. Index.html, followed by the git status. There are no untracked files because this file is tracked by Git, hence the status shows it's modified. Execute git commit. This commit command is rejected by Git because the file has not been staged yet. So you need to execute the git add command to stage this file. Commit the file after staging. Execute git commit. Git opens a default text editor because the commit message -m flag was missed. In this case, it's the Sublime text editor because the commit message using the -m flag was missed. Enter the commit message. Save and exit the text editor. Now that the commit is successful, let's execute the git status. There is nothing to commit in the branch master. Execute git log to view all the commits in reverse chronological order. Git log shows an exhaustive list of commits associated with the particular commit ID, author, and email. To get the one-line output, execute git log one line. The git log displays the message associated with every commit. Now that you have learned how Git workflow is executed, let's learn about the next operation in Git. Git is a version control system. One of its key features is tracking changes. Let's understand how Git does it. Tracking changes in Git refers to its ability to identify the changes between the different versions of the same file, spread across the working directory, staging area, or the local repository. Let's recall Git's three-stage workflow, with the commands associated at various stages. Git diff is used to display the changes between a modified file in the working directory and its staged state. Similarly, Git diff staged helps to track changes between the staged file and the last commit of the same file. The latest commit of a file is identified by a pointer called head. Shown here are three versions of a file in the repository. The last commit is marked head. The penultimate is referred to as head 1, and the antepenultimate is called head 2, and so on. Note, command git diff staged is similar to git diff head. When the number of commits increase beyond a certain count, it's difficult to use the head command. In such cases, use the hash code. Example, git diff commit hash code. Let's understand this better through a demonstration. Let's see how Git compares different commits for different versions of files maintained within the working directory and its last staging area. You have a particular file in the current directory. Execute git status. You are in branch master with nothing to commit. This indicates that the staging area is in sync with the last commit. Execute git diff index.html. No difference is indicated because the file in the working directory is the same as the one in the staged area. To understand how Git tracks changes, let's make a few changes to this file. Open the file in VI or any text editor of your choice. Add a head and body section in an HTML and save. Execute the git status, which will display the change in the file within the working directory. The next task is to identify the difference between this and the last staged file. Execute git diff index.html. Git indicates these changes in the form of additions through the plus sign and deletions through the minus sign. Since the working directory file is in sync with the staged version, the git diff command will not display any differences. Execute git diff staged. Now, let's review the existing commits. Execute git log one line. This is the latest stage, containing HTML in a single line. These lines in the staging area consist of all the text that was just edited. Before you commit the changes, execute git diff staged head. This indicates the exact changes from the last commit. To refer to the second last commit, execute git diff staged head 1. This is an empty file. Now execute the git status and git commit. This shows that the working directory, staging area, and the commits are in sync. Let's execute the git diff command to confirm. Git indicates 3 commits. Each of these commits has a unique code, which can also be used to refer to a particular commit. Now let's execute git diff for all these commit IDs individually. Git list all the differences. This is how tracking is done in Git. Let's learn about the next operation in Git. Now that you have understood the concept of commits and how Git tracks files, it's time to take a step further to understand how to revert to earlier commits in Git. Execute git log command. This will list down the details of each commit associated with the particular file. Execute git checkout, followed by the details of the commit you want to refer to. This will stage the file. Execute git status. This will share the command to unstage the file. Execute git reset. This will remove the file from the staging area and bring it back to the working directory. Let's understand this better through a demonstration. Let's demonstrate Git's ability to revert to the earlier commit version. Let's begin with checking the content of our repository. Execute git log 1 line. Git indicates 4 commits in the repository. The cat of file A displays these 4 lines. An additional line is added with each of the comments in the repository. Now let's make changes in line 4. For this, the version has to be restricted to line 3. Execute git checkout head 1. We are using head 1 because it's the penultimate commit, followed by the file name. Next, do a cat of file A, which indicates that you have switched to the earlier version. Now, let's check the status of this file. Git indicates that the file is being staged and that it needs to be committed. Execute git commit, followed by the git status. Next, execute the git log, which displays that there is an additional version. You have successfully reverted to the earlier version using the head command. Let's discuss another way of doing this. Suppose you need to revert to the first version. Execute git checkout version code. Next, check the contents of the file. Git indicates that it has been reverted to the first version. Now, execute the git status. Git indicates that the file is staged and the changes need to be committed. Execute git commit. Add the commit message. Next, execute the git log. Git indicates one additional commit that corresponds to the changes that were just made. Note, you can use the git checkout command to revert to an earlier version. You can refer to the commit IDs. Once you check out, the file is automatically staged, already added. All you need to do next is commit. This concludes the demo on reverting to earlier commits in Git. Let's understand the next operation in Git. Now let's understand how to delete files in Git. Files in Git can be deleted by executing git rm filename. This command deletes the file from the staging area and the working directory. What if you want to delete the file only from the staging area? You use the git rm command with the cached flag, git rm cached filename. Execute git status to confirm. Note, this file will be untracked as it is removed from the staging area. Even when a file is deleted, its commit history is still present in the repository. A user needs to identify the version that needs to be restored and revert the deletion. This can be done by using the git checkout version filename command. Here you have 3 files in the directory. Let's check how many of them are staged. Execute git ls files stage. Git indicates that all 3 files are staged. Execute git rm a.txt. This command deletes a.txt file from the staging area and the working directory. Let's confirm. Start with the staging area. Execute git ls files stage. Git indicates that the file a.txt is deleted from the staging area. Next, let's check in the working directory. Execute ls-lrt. Git indicates that the file a.txt is deleted from the working directory. In order to delete the file only from the staging area, use the cached flag. Execute git rm cached b.txt. Now let's check whether the file is deleted from the staging area and the working directory. Execute git status. In both cases, you have removed the files from the staging area. In the first case, you have removed a.txt from the working directory, so Git no longer indicates whether the file is tracked or untracked. However, if you consider the file b.txt, Git indicates that it is untracked because it is still present in the working directory. Let's delete this file from the working directory. Execute rm b.txt followed by the git status. Once Git confirms the deletion, execute git commit. Followed by the git log. How do you revert files that are already deleted? Even when a file is deleted, its commit history is still present in the repository. A user needs to identify the version that needs to be restored and revert the deletion. Execute git checkout head1 a.txt and git checkout head1 b.txt. This brings the file back to the staging area. Check the git status to confirm the files are visible. Add the files again, followed by git commit. Execute the git status, followed by the ls-lrt command to view the status of the file. This is how the delete operation is performed in Git. Let's learn how to ignore files in Git. Sometimes during development, temporary files are added to the repository, which you don't want to track or commit. This can be done by using a simple ignore command in Git. Let's see how. To ignore a file or to instruct Git not to track or commit a file, add that file in git ignore. You can store file name and pattern in the git ignore file. You can override the file name and the file pattern mentioned in git ignore by using the -f flag. When an attempt is made to commit the files added to the ignore list, Git sends a notification to the user. It also lists the -f option in the output. Let's understand this with the help of a demonstration. You have 3 files in the current directory. Let's start with a git status. You are on branch master and the tree is clean. Execute git log 1 line. Next, you modify the a.txt file. Execute echo modify a.txt a.txt followed by a git status. Git is tracking the file. Now let's create an ignore file. txt. All files in this format will be ignored by Git. Execute git status and git add. This will bring the file to the staging area. Now, if you create any file with .txt, Git would be able to identify the pattern and ignore the file. What if you want to add a file that is in the git ignore file or pattern that matched the entry in the git ignore file? Let's consider a file c.txt. Execute the git add command. Git throws a warning. The file matches the pattern in the git ignore file. Execute git add -f c.txt followed by the git status. The file is added in the staging area and is ready to be committed. Let's try adding the b.txt file. Followed by the git status and git commit. Any new changes to C would always be tracked by Git. Let's introduce a file d.txt. As you can see, this pattern is ignored by Git. This concludes the ignoring in Git. Let's learn about the next operation in Git. Let's now understand the steps to rename files in Git. Execute the git mv filename new filename command. Execute git add followed by git commit command. Run the git status to ensure that the file is renamed. To understand this better, let's quickly execute the commands in a demonstration. You have two files in the current directory. To rename, execute git mv a.txt aa.txt followed by the git status. Git has figured that you are trying to rename the file because the file content is the same. Here, you have used the git mv command to rename the file. Execute git add, git commit, followed by the git status. Let's assume the Unix move mv command has been used instead of git's git mv command. Execute mv b.txt bb.txt. Git displays that b file is deleted and bb.txt file is ignored. because the getIgnore matches the pattern bb.txt. To overcome this, let's move aa.txt to aabb.t file. Execute getStatus. This shows the deletion of aa.txt and the addition of aabb.t file. Execute getrm aa.txt, followed by a git add of aabb.t and getStatus. GetStatus command has identified that this was a rename action. Let's remove b.txt. Execute getStatus followed by getCommit. You have successfully executed the rename operation in Git. This concludes all the Git operations in this lesson. Now, let's list the important points you have learned so far. Git-init command is used to create a repository in Git and create a hidden directory that stores all the metadata required for it to function. Git has a three-stage workflow. Files in Git are staged in a git/index file called the staging area or index. Subsequently, one can commit them to the local repository. Git allows you to add, commit, ignore, rename, revert, delete, modify, track, and view the status of the files in the repository. In the next lesson, you'll learn about GitHub and its features. Hello and welcome to the third lesson of the Git course offered by Simplilearn. This lesson introduces you to GitHub and its features. In this lesson, you'll learn about GitHub and its features, how to create a repository in GitHub, manage and merge file changes across repositories, and push and pull commits across repositories. Let's understand the basics of GitHub. GitHub is a popular web-based Git repository hosting service, which provides web interface for the users to upload files from their local repositories. It copies the entire commit history from the local repository to the remote repository. The remote repository is referred to as origin, whereas the local repository is referred to as master. GitHub provides all the distributed version control functionality of Git with additional features for publishing your projects and also for collaboration. GitHub, with over 35 million repositories, is the largest host of source code in the world. It's used by numerous organizations worldwide, including NASA. Let's explore GitHub and its features through a demonstration. This demo will familiarize you with the website https://github.com. As you can see, there are some links provided such as personal, open source, business, and explore. Now let's explore each one of them. When you click on personal, you'll see that GitHub is home to all kinds of software projects, from basic programs to the most popular apps. The open source link shows you that there are millions of open source projects on GitHub. When you click on the business link, you will get two options on how to work with GitHub. You can either host your source code on GitHub servers, or you can have the source code hosted on your servers so that you would have GitHub working on your servers. Now you can store your files in a public cloud or a private cloud and install GitHub over it so your data is within your reach. Clicking the Explore link will display a lot of project files that are right now hosted on GitHub. If you click on More Showcases, you can see some more categories. To explore one of the categories, click Text Editors, and you will be able to see all the editors under Text Editor listed out. Click the Atom repository, and you will be taken into a new tab, Code, which lists out all the codes associated with Atom. You can also see the directories, subdirectories, and files. At the bottom, the readme.md file gives you a brief description of the page. Click on Watch to watch over the changes to this particular repository. Click on Star to give rating. As you can see, there are 32,072 star ratings for the Atom project. You can also click on Fork which means that you can fork out a snapshot based on the latest snapshot in this particular repository, and you can continue to work on them individually. Now, sign into the GitHub login page with your username and password. When you are done, click on Sign Out to log out. Now that you are familiar with the GitHub, let's see how to create a repository in GitHub. You can create a repository in GitHub using two protocols, that is HTTPS and SSH. Let's understand how this is done. Start with the set of commits in the local repository that has to be duplicated in the GitHub repository. Go to GitHub and log in. Create a new repository. Follow instructions. Create a symbolic link to GitHub. Push from local repository to GitHub. Let's execute these steps in a demonstration. In this demo, you'll learn how to create a remote repository in GitHub using HTTPS. Let's start from the local repository. Execute git status to fetch the status. You are in branch master, and there is nothing to commit. The working directory is clean. Execute ls-lrt to get the details of the files in the local repository. Let's list down the commits. Execute git log, one line. Git indicates two commits. Let's go to GitHub and create a repository. Step 1. Enter your credentials to sign in. Click on the new repository icon. Enter the name of your repository. Let's make this repository public so that it is accessible to everyone. GitHub also displays an option to initialize this repository with a README. GitHub also has an option to add files to the ignore list. Now, click on the Create Repository icon. Git enables moving the files from the local repository to the remote repository using either the HTTPS or SSH protocol. When you swap the protocols, a different link is displayed. So the first step is to freeze on the protocol. Git provides an option to create a new repository from scratch or create from an existing repository. Since you already have a repository, let's execute these two steps. Git indicates that a remote repository can be added and identified with the keyword known as origin. Git indicates the URL to be picked up based on the repository. Let's copy this command. Go back to the local repository and execute it. Next, view the remotes. Execute git remote -v. Git indicates that both the fetch and push operations can be executed using the same command, which means you can use fetch using one repository and push it to the other repository. So execute git push origin master. Now, if you look at the statement here, it is the same command, except for the -u flag. This flag assumes that henceforth you would always push from the master to origin, which should not be done at this point. Go to master and push from there. When Git asks for a username, enter it. A pop-up asking the password appears. Key in the password in the dialog box. Git has now performed the compression operation and pushed the local repository to the remote repository. The Git status is unchanged. Refresh the screen in GitHub. You will see that the two files from the local repository have come in. Let's check the contents. To verify whether the file is updated, execute the cat of that file. Git displays the exact contents. Now let's see the commits. Click on Code. There are two commits displayed here, which is the same as the commits in the local repository. Match the commit ID to confirm. So this is how you can create a remote repository using the HTTPS protocol. Let's now continue to understand how a repository can be created using an SSH protocol. Ensure that the local repository is ready. Create an SSH key or SSH keygen. Configure GitHub with SSH public key. Create a GitHub repository. Push from local repository to GitHub. Note the SSH key helps you create a repository without a username and password. Let's understand the process better through a demonstration. Let's create a remote repository in GitHub using the SSH protocol. To begin with, execute git status. Git indicates that there is nothing to commit and the working tree is clean. Now let's look at the files inside the repository. Execute ls-lrt. Next, execute git log one line. Git indicates two commits. Next, execute SSH keygen, which will fetch a public and private key for use. Let's choose the default location. Hit Enter. As there is no passphrase, hit Enter twice. Now you will see the key has been generated. Git also indicates the location of the key. Copy the location into the clipboard and paste it into the command interface. Next, copy the public key into the clipboard. Go to the GitHub page and log in. Now go to View Profile and More and click Settings. Next, click SSH and GPG keys. There are no SSH keys with access to your account. So let's add the SSH key by clicking New SSH Key. Now enter My SSH Key into the title field. In the key field, paste the content that you copied into the clipboard and click Add SSH Key. Since you added the key, you will not be prompted for username and password at every instance. Go back to the repository by clicking the home page icon. To create a new repository, click New Repository. Key in the repository name. Keep the default settings, and click Create Repository. Now you will receive a prompt with two options. One of the options is creating a new repository from scratch, and the second option is creating a new repository from an existing local repository. Click on the SSH protocol. The command is to add a remote repository, and the repository is identified by a keyword, origin. Now, let's go to the local repository. Execute clear. Right-click and paste the content from the clipboard. Hit Enter. Execute git remote -v to list the repositories. Next, execute git push origin master to push from the master repository to the remote repository. You have just created a new SSH key. A prompt will check whether or not you want to continue to authenticate the first time. Enter yes to continue. Observe here the compressing objects and writing objects are 100%. Now let's go to the remote repository. Click the refresh icon to refresh the page. You will be able to see both the files. Click index.html to view the contents of the file. Now click Code. Git indicates two commits. Click the commits to view the commit IDs. To verify the commits, let's go to the local repository and execute cat index.html. Git indicates the same content. Next, execute git log one line. Git indicates the list of commits. The latest commit is 12ff076, which is the same as the one in the remote repository. So in this demo, you have learned how to create an SSH key, how to configure the key in the remote repository, and how to push using the SSH protocol. Now, let's see how to pull commits from GitHub. In this section, you'll learn how to pull commits from the remote repository in GitHub and into the local repository. You have learned how you can copy the contents of the local repository into the remote repository using a push command. But there are instances when a user makes changes in the files in the remote repository. These changes have to be pulled into the local repository to view and integrate them with the codebase. Use the git pull command to execute this. Let's understand this in detail through a demonstration. Let's see how to pull commits from the remote repository into a local repository. To begin with, execute git status. Git indicates that you are in the master branch and there is nothing to commit. The working tree is clean. There are two commits in the local repository. Let's look at the commits in the remote repository. There are two commits here as well. Let's make some changes in the files here to create a new commit in the remote repository. Click readme.md. Next, click the edit icon and edit. Commit the changes on GitHub. Next, click on Code tab and repeat the same for index.html file and commit. Go to the Code tab. Git indicates 4 commits. Switch back to the local repository. As you can see, there are still only 2 commits. The 2 additional commits that were created in the remote repository are not reflected here. Execute git status. It is still in the initial stage. Let's pull the commits that were just created from the remote repository. Execute git pull origin master. Git indicates that 2 files have been pulled and displays the additions. Here, 1+ indicates the addition of a line addition for readme.md, and 2++ indicates addition of 2 lines in the index.html file. Now, execute git status. It shows the same initial status and indicates that there is nothing to commit. Next, execute git log 1 line. Git indicates 4 commits. Now, as you can see, the 2 commits from the remote repository are added in the local repository. This is how you pull commits from GitHub. Let's now understand how to collaborate between the local and remote repositories. Collaboration is an important aspect in Git. It's important to collaborate between the local and remote repositories to ensure a smooth flow of development. Let's understand how this is done. Git pull and git push are the 2 commands in Git used to collaborate between the local and remote repositories. Let's start with both these repositories synced up. Now consider a scenario. Suppose a developer code is being reviewed and review comments are committed in the remote repository. How do you collaborate? The developer pulls these comments into the local repository and makes the appropriate update, which is then pushed back to the remote repository. This can be done using the pull and push commands in Git. Let's understand how this is executed through a demonstration. Let's demonstrate how Git helps in the collaboration between the local and the remote repository. Let's assume a code reviewer reviews the codes that is added here by the developers. Let's start with the review of index.html file and adding the review comments. To do this, choose the edit icon and insert comments. Next, add a commit message and commit the change. Now let's switch to the local repository and execute git status. Git indicates that you are in branch master with nothing to commit. Next, execute git log 1 line. Git indicates 4 commits. Notice the latest commit made in the remote repository is not reflected here. For this, pull the commit to sync the local with the remote repository. Execute git pull origin master. It shows that 1 file has been changed and there is 1 insertion. When you do a cat of index.html, you find that 1 comment has been added. So now you need to make changes as per the reviewer's comments. Let's open the VI editor. Save and exit. Now, Git status would show that the file has been modified. Execute git add, followed by git commit. Next, execute git log, one line. Git indicates 6 commits. Git status is now clean. The reviews are incorporated. But the remote repository still only contains 5 commits, which means you need to push the last commit from the local repository to the remote. Switch back to the local repository and push the changes. Execute git push origin master. The remote repository has 6 commits. The reviews have been incorporated, which can be viewed when you open the index.html file. This is how Git helps us collaborate across repositories. Let's now see how Git manages multiple commits. Let's learn how Git manages multiple commits to the same file. Let's start with the local and remote repository, which are in sync with each other. Let's assume that there are simultaneous changes to the same file at both the repositories. How does Git manage these changes? When you attempt to push your changes to the remote repository, Git identifies that the remote has changed. Git rejects the push action and suggests to pull changes from the remote repository. Once the changes are pulled, the remote commit comes to the local repository, and Git would do a merge with the local changes. This forces an additional commit at the local end, which can be pushed to the remote repository later. Let's understand this better through a demonstration. Let's learn how Git manages multiple changes to a file in the local and remote repository. Execute git status in the local repository to know the working tree status. Note that you are in the branch manager and the working tree is clean. Execute git log, one line, to check the file logs. Git indicates 6 commits in the local repository. Let's check the file log in the remote repository. You can observe that there are 6 commits in the remote repository too. So the local repository is in sync with the remote repository. Now let's edit the index.html file. Execute vi index.html to open the index.html file in the editor vi. Let's make a few changes. And save it. Execute git status. Git indicates that the index.html file is modified. Next, execute git add to add the changes to the file. Commit the modification with the desired message. Let's now check the file log. Execute git log, one line. Git displays the recent modifications. Now, edit the same file in the remote repository without pushing the changes made in the local repository to the remote repository. Navigate to the code section in the remote repository and select index.html file. Use the edit icon to edit the file. Make the required changes. Add the commit message and commit. Now there are 7 commits in the remote repository. Note that different changes have been carried out in the local and remote repositories. Let's switch to the local repository. Execute git log, one line. Git indicates 6 commits. Next, execute git push origin master to push the changes made in the local repository to the remote repository. Now you can observe that the update is rejected as the remote contains work that you do not have locally. To resolve this, integrate the remote changes before pushing again. Execute git pull origin master to pull the changes from the remote repository to the local repository. This merges the changes made in the remote repository to the local repository. Next, execute git log, one line, in the local repository. The remote changes are displayed. Git indicates 9 commits. In addition, you can see the changes made in the local repository are merged with the remote repository. Open the file in the VI editor. The changes made in the local and remote repository are displayed. Let's check the remote repository. There are 7 commits. Observe that the changes made in the local repository are not reflected in the remote repository. In the remote repository, you can see that the changes made in the local repository are not reflected. Now, execute git push origin master to push the changes made in the local repository to the remote repository. You can now see that the command is executed successfully. Let's check in the remote repository. You can observe that there are 9 commits now. Open the file to check whether the changes made in the local repository are reflected. Yes, the changes are reflected. This concludes the demo on how to manage multiple changes to a file in the local and remote repository. Let's now understand how Git merges the file changes. You have already learned about the merging operation in Git. In this section, you will learn how there are two users, user A and user B. User A wants to edit a particular line in a file within the local repository. On the other hand, user B wants to edit the same line in the same file within the remote repository. When user A attempts to pull the change, Git shows a conflict and suggests to resolve the difference manually. In such cases, use the git merge command after you resolve the conflict manually. Let's understand how this is done through a demonstration. You have already learned how Git handles multiple commits to a file. But now let's create a conflict, which means updating the same file differently in the local and remote repositories and observing how Git manages it. To begin with, execute git log one line to fetch the log of commits. Here, E1A4978 is the latest commit. Let's check the list of commits in the remote repository. Notice that the commits in the remote repository are in sync with the local repository. Let's go back to the code and make a change. Click on index.html and edit. Add a commit message and commit the changes. The changes made are reflected, and now there are 10 commits. Let's go back to the local repository and make changes to the index.html file. Change the repository to local and save the file. Execute git status. It shows that the file is modified. Next, execute the git add followed by git commit. The git log indicates 10 commits. The latest commit is 2A2F6DD, which doesn't match with the latest commit in the remote repository. So if you execute git push origin master, Git rejects it and asks to do a pull instead. Execute git pull origin master. Git indicates a conflict and intimates that the auto merge has failed, so the conflict has to be fixed manually before the commit. So if you look at the master in the first case and the master or merging here, it indicates that the merge has not been done yet. Execute vi index.html. Here you would notice lines 9 through 13 show the changes at both ends. Line 10 indicates the change in the local repository, and line 12 shows the changes in the remote repository. So at this point, you need to decide what to retain and what to get rid of. Let's retain the changes at the local end. So delete the changes from the remote repository and save. Execute git status. Git indicates that the file is being modified and suggests to commit after the conflict is resolved. Before that, execute git add, followed by the git commit. Next, execute git log. You can see the change that was made with the commit ID starting db93. Let's push these changes to the remote repository. Execute git push origin master. Now let's go to the GitHub code tab and click on index.html. The file is now modified and added to the local repository. There are 12 commits in the remote repository, and the latest commit, db933bc, is the same as in the local repository. So you have the entire history copied to the remote end. Moreover, it is synced to the latest changes in the file. The changes in the files have been successfully merged across repositories. In the next section, you will learn how GitHub tracks issues. Let's understand how to raise and track issues in GitHub. In GitHub, issues act as a place where you can raise bugs and track them. You can list and create the issues and attach a label or milestones to them and then commit, which can be tracked. Let's explore how this works through a demonstration. Let's look at the issues tracking in the GitHub. Click the Issues tab next to the Code tab in GitHub. There is also a Filter tab in the left-hand side, which allows you to filter the issues. Issues can either be assigned to someone or mention someone. Based on what you choose here, there would be macro changing. There is also a tab called Labels. Initially, when you create an issue, this can be associated with any of these existing labels. There is an option to create a new label as well. Next, you have a milestone containing the timeline, which can be associated with the project or a release. When you click a milestone and a calendar, a due date appears. Just pick a date, add a title, and create a milestone. Go back to the Issue tab and create one. Add a label and associate it with the milestone. Click Submit New Issue. The issue is indicated in the Issue tab, which can also be assigned to someone. You can also add labels or filter by author. Let's add some comments. Let's create another issue. There are 2 issues at this point. Let's edit issue number 1 and add a new comment. You still have 2 open and 1 closed issues. Let's try and close an issue. In the comment that you added, there is a hyperlink that takes us to the issue directly. You can mark this as closed. Select it and mark Close. If you look at the milestone, it shows the task is 50% complete because you have closed 1 out of 2 issues. So if you close the other issue, It shows you have 0 open and 3 closed, and the milestone is 100% accomplished. This is how you create and track issues in GitHub. Now, let's summarize what you have learned so far. GitHub is a popular web-based Git repository hosting service that provides web interface for the users to upload files from their local repositories. You can create a repository in GitHub using 2 protocols, that is HTTPS and SSH. Git pull and git push are the 2 commands in Git used to collaborate between the local and remote repositories. In GitHub, Issues acts as a place where you can raise bugs and track them. In the next lesson, you'll learn about branching, merging, and rebasing in Git. Hello, and welcome to the fourth and the last lesson of the Git course offered by Simplilearn. This lesson helps you to understand the concepts of branching, merging, and rebasing in Git. In this lesson, you'll learn about the concepts of branching, merging, stashing, rebasing, and cloning in Git. Branching is a very important concept in Git. It helps in reducing the errors and protecting the contents of the main repository. Let's learn about it in detail. Branching in Git can be compared to the branches of a tree. Just like the tree has different branches to accommodate a set of leaves, Git branches contain different lines of code. It is a separate workspace, usually created when you need to experiment or test something without impacting the main code base. In addition to these, a Git branch is used to manage releases and create hotfixes for the production branches. Let's look at an example. Let's start with the master branch, which is created by default when a repository is initialized using the git init command. Let C1, C2, and C3 be the commits associated to the master branch. Now, let's create a new branch called myBranch, which would have the snapshot of the master branch and includes all the files and commit history. Now, refer to a new working directory and staging area, which is different from the master branch. The desired change can be made to this branch, which can later be merged to the master branch. A branch is a method of requesting a new working directory and staging area, where a different line of code can be executed. Later, this can be merged to the main code base. Note, a Git branch is just a pointer to the commits. It does not change the contents of the repository. A Git branch lets you create, list, switch, and merge branches. Let's now learn the commands associated with each of these functions. Git branch, branch name, creates a new branch. Git branch, list all branches in the current repository. Git checkout, branch name, switch to branches. Git merge, branch name, merge branches. Note, to create a new branch and switch to it, execute git checkout -b branch name. Let's understand the use of these commands better through a demonstration. In this demo, you'll learn how to branch in Git. To start with, let's execute the git status command. This shows that you are in branch master, and additionally, it displays the same branch name in the command line. The next step is to find out the number of branches present. Execute git branch. There is only one master branch, which is usually created by default when a repository is initialized using the git init command. There is an asterisk around the branch name displayed by Git. This usually represents an active branch. In this case, master branch is active. Let's create a new branch. Execute git branch, branch name. The branch is created, but the master branch is still active. Before you switch to the new branch, let's find out the existing commits in the master branch. Execute git log, one line. This displays the 3 commits associated with the master branch. To switch to the new branch, execute git checkout, branch name. you have now switched to the new branch, and the output is reflected in the command line too. Execute git log one line to view the available commits at the new feature branch, which is the same as the master branch. Note, when a new branch is created, the complete commit history of the master branch is replicated. Our feature branch head also points to the latest commit as the master branch. How do you make the commits to this new branch? For this, you need to make changes in the feature branch. Open index.html and make the required changes. Execute git add and git commit to move this to the staging area. Next, execute git log command to list all the commits associated and display the last commit. Git indicates a new commit, which is not present in the master branch. Let's verify this. For this, you need to switch to the master branch. Execute git checkout master. You are in master branch now. To fetch the list of commits in this branch, execute git log one line. Notice the latest commit on the feature branch is not visible in the master branch. How do you create a branch and switch to the new branch using a single command? Execute git checkout -b branch name. In this demo, you have learned how to create, list, and switch branches in Git. Let's understand git merge in detail. Before you merge two branches, it is important to analyze the difference between them. This helps in preventing conflicts while merging. The git diff command is used for this purpose. You can also view the difference using the Git GUI tool, which provides a pictorial representation of the changes across branches. The GUI tool comes in handy when there are multiple users working across multiple branches. Now that you have the basics right, let's understand how to merge in Git. Switch to the branch you want to merge to. Execute the git merge command followed by the branch you want to merge from. Let's understand this better through a demonstration. In this demo, you'll learn how to merge branches in Git. Master branch now, and there's nothing to commit. There are 3 files and 3 branches. Let's consider any one of these branches to demonstrate the merging operation in Git. Execute git checkout selected branch name. Next, execute git log one line decorate graph. Git displays an additional commit because you have branched out from the master. Let's find the differences between the master and the feature one branch. Executing the git diff command is one way of getting the list containing the differences. However, you can also use the git GUI to view this pictorially. Go to My Program Files Git directory, CMD directory, Git GUI. Execute the application Git GUI. This opens a dialog in which you can open a particular repository. This opens another dialog wherein you can click on repository and visualize all branch history. The UI here shows the current scenario. The 3 commits in master and the additional commit in the Feature-1 branch is also displayed here. There is also another branch called the Feature-2, which is at the same level as master. At this point, let's find out the difference between the master and the Feature-1 branch using the git diff command. Execute git diff master, Feature-1. Git indicates the addition of an empty line and addition of a line which refers to paragraph 1 in Feature-1. Now let's merge the Feature-1 content with the master branch. Note, you need to be in the repository where you want the merge to be. You are right now in the master branch. Execute git merge Feature-1. Git indicates that one file is changed. Now, to check this, let's execute the git diff command. It does not show any difference because the files are now merged. Execute git log in master to view the list of all logs. Here, the master and feature points to the same commit. In such cases, Git uses the fast forward method, which will be discussed later in this demonstration. If you refer to the GUI tool, master and Feature-1 are 2 different commits. When you update, the master branch moves to the latest commit in the Feature-1 branch. This was a simple merge, wasn't it? This was simple because the same file was not being updated across multiple branches. The update was done only in one branch. There can be instances where you may have to update the same line. In those cases, merge is a bit complex and may involve resolving a few conflicts. So let's try this. Navigate to the Feature-2 branch. Let's view the index file. Rename Welcome to My Project. This is done to create a conflict. Initially, only 2 lines had been added, but there was no change made to the same line, so there was no conflict while merging. Let's create a conflict and see how Git resolves it. Let's update and modify this line. Next, execute vi-index.html and make necessary edits and save the changes. Next, execute the git add and commit commands. Next, execute git checkout master to switch to the master branch and attempt the merge. Before merging, let's execute the git diff command to understand the differences and whether Git displays it. indicates that the lines the master branch got from merging with feature 1 are missing, and it also shows the difference to the line you made by changing to our project. Let's execute the git merge command to merge the changes made. Git merge has failed because the files were in conflict. This needs to be resolved and then committed. Execute vi-index.html to display the conflicts, modify, and save it. Execute git add followed by git commit. Next, execute git log. Notice that there is a feature 2 branch from where you merged into the header. Let's go back to the GUI tool. You can spot feature 1 branch here. Once you execute the merge command, all these will point to the same commit. Here, the blue circle is linked to the yellow because feature 2 changes have been merged into the new version of master. Now that you have understood how merging is done in Git, let's understand the types of merges in Git. There are 2 types of merging in Git, the fast-forward and the recursive merge. Let's understand them in detail. Git employs a merge algorithm based on the context it has to merge to. Fast-forward merge is employed when you merge into a branch, the latest commit of which is your parent. Look at the branch flow shown here. You would notice that B is the parent of the feature branch. Also, there are no commits made to the master after B. When a git merge is executed in this scenario, Git moves the master label to the latest commit brought from the branch, as there are no commits in the master. Fast-forward merge is applicable in cases where a hotfix is needed over the production code base. This is typically used to fix bugs. Let's understand this better through a demonstration. In this demo, you'll learn the concept of fast-forward merge in Git. To begin with, you are in the master branch, where B is the latest commit. Let's create a branch followed by 2 subsequent commits. You need to do a merge into the master branch. When an attempt is made to merge, it moves the label master to the latest feature branch. This is because all the commits in the feature branch are inherited from the latest master commit. The master label moves down to point at the latest commit on the feature branch. Execute git branch. Let's focus on feature 3 at the moment. Next, execute git checkout feature 3 to switch to feature 3. This is branched out from the master. Let's execute the git log command. Git indicates the master branch is at commit ID starting 423. But a feature 3 has been branched out and 2 additional commits have been made. Let's view this pictorially. This is the master branch with the latest commit. On the other hand, Feature 3 branch contains 2 additional commits that has branched out from the latest commit on the master branch. To view the difference between the master and Feature 3, execute git diff master Feature 3. Git indicates the addition of 4 lines in the Feature 3 branch, namely 2 empty lines and 2 lines referring to paragraphs 2 and 3. You can see them indicated by green plus signs. Here you are still in the master branch. Let's do a git merge of Feature 3 branch into the master branch. Execute git merge Feature 3. This will merge the Feature 3 branch into the master branch. So, what did you observe? Since 2 additional commits were created on the feature branch while merging, Git has moved the label down instead of creating a new commit. It may interest you that in such cases, Git uses an algorithm known as the fast-forward algorithm. On cases where all your branch commits are still branched out from the latest commit in master. So if you look at the status now, 4 lines have been added and 1 file has been modified. Let's execute git log to analyze the commit history. Git indicates that the commit starting D9 was the latest commit in the Feature 3 branch. Observe that the master is indicating the same commit. If the UI is updated, the master branch label moves to a different position. Now that you have understood how Git employs the fast-forward merge, let's learn about recursive merge. Recursive merge is the default merge employed by Git to deal with multiple merge bases. Git creates a merge base and merges recursively. Let's understand this better through a demonstration. Let's demonstrate how Git facilitates recursive merge. A recursive merge is done when you have a branch in the master which is not the parent of your branch commit. Here, B is the parent of C and D. When you try to merge, Git realizes that there is a new commit in the master branch which is not the parent of C and D. So unlike the fast-forward merge, in recursive merge, Git creates another commit called F and brings all the changes into this additional commit. Let's execute git log command in the git bash. Git indicates that you are in the Feature 1 branch. Git indicates 3 commits. The latest commit, 77498C9, is the commit on master where the Feature 1 was branched out. Now, if you look at the above statements, we are on the master branch. You will find only 1 commit. Now, let's create another commit in the master branch. Let's switch to the master branch. Execute git checkout master. Next, execute git log and modify the index file. Next, execute git add followed by git commit and git log. First, the commits are viewed on the master branch and then the Feature 1 branch. you will notice an additional commit on master branch, which is not the parent of the feature-1 branch. Let's do a git merge. Execute git merge feature-1. This opens the default text editor. Save the file and exit the editor. Observe Git has done an auto merge and has used the recursive merge. Git displays the changes in the index.html file. Let's display the contents of index.html. The two changes in the commit are from the branch. The new style blocks added here are from the latest commit in the master branch. Next, execute git log. Git displays the merge from feature-1 and shows an additional commit. The commit ID starting 77 was the initial commit, and these two branch commits were created. When an additional commit was created in the master, these commits were merged into this. Let's view this in the GUI tool. Here is the new master commit, using which these additional commits were created in the feature branch based on the parent master commit. This is the new commit, which is not dependent on the other two commits. When these commits are merged, the master commits are merged with the branch commits. The master indicates the new commit. So this is how Git does a recursive merge. But how do you resolve conflicts during merge? Let's explore. At times, merging is tricky and can lead to a conflict. Let's understand how to resolve them. You would have understood that it is quite easy to merge branches in Git. When you integrate one branch into another, Git figures how these changes can be integrated all by itself. Then what causes conflicts? Let's consider a scenario to understand this. Suppose two users change the same line in a file. One of them wants to delete it, whereas the other just chooses to modify. In such cases, Git is unable to find what is correct, and hence it shows the file to be in conflict. Now, how does Git resolve these conflicts? There are times when Git resolves this automatically, but it generally asks for a manual merge and highlights the problem area. Let's understand this step by step through a demonstration. In this demo, you'll learn how Git manages the merge conflicts across branches under different conditions. To begin with, you are in the master branch with nothing to commit at the moment. Execute git log to view the history of the commits associated with the master branch. Git indicates that there is only one commit and no additional branch. Let's start by creating a branch. Execute git branch name. The next step is to switch to the new branch. Execute the git checkout command. This branch contains the same commit as in the master branch. These two files are in the new branch. Let's make a few modifications. Delete the index.html file. Use the getrm command. This remove command would delete the file from the staging area as well as from the working directory. Git status confirms the deletion of the index.html file. Let's execute git add followed by git commit. When you execute the git status now, it shows that you are in the Feature-1 branch. Let's switch to the master branch now. Next, execute git diff to fetch the list of differences between the master and Feature-1 branch. Git indicates the files that are deleted and highlights the missing pieces. Now let's merge the Feature-1 branch into the master branch. Execute git merge Feature-1. Execute git log to list down the commits. Because Git has done a fast forward, the commits remain the same. Observe that the commit IDs are the same in this case. The master label in the UI has moved down to the latest commit on the feature branch. This is how Git would manage merges across branches when files are deleted. Now let's understand how Git resolves merge conflicts across branches. In this demo, you'll learn how Git manages merge conflicts when files are merged across branches. To begin with, you are in the master branch with one commit. Also, you have an additional branch called Feature-1 that has the same commit as the master branch. Let's create a conflict in the master branch. Let's change the contents of the index.html file. Maybe add a new line. Save and exit. Now, execute git add followed by git commit. Next, execute git status followed by git log. Git displays two commits. Let's switch to the Feature-1 branch. Execute git checkout. Next, execute git log. Git indicates there is one commit, which is the same as the master because Feature-1 is branched out from the master branch. Our HTML file contains only one line. Let's modify this to create a conflict. save and exit. Now execute git add followed by git commit. Next, execute git status followed by git log. Git indicates 2 commits in the Feature-1 branch. Let's switch back to the master branch. Execute git checkout master. If the git log is executed, Git shows 1 additional commit in addition to the initial commit. If this is compared with the commit in the feature branch, these two represent the 2 commits done at the 2 branches. Execute git merge feature1. Git fails to do an auto merge and indicates a conflict. Let's resolve the conflict and commit. Let's open the file to view how Git has edited it. For lines 3 to 6 here, Git has incorporated the changes for both master and feature1 branches. Git suggests to resolve this conflict manually. Line number 3 is changed in the master, and line 5 is changed in feature1. This is what is creating the conflict. Let's resolve this manually. The changes in master can be retained, and the other changes are deleted. Execute git status. Git shows that the file is modified. Next, execute git add followed by git commit and git log. Git indicates that the changes are brought from the feature branch, and there is another commit where the merge was done manually. Let's switch to the feature branch and execute git log. Git still indicates 2 commits. Here, commit A7 went to the master, and this file is not in sync with the master. Let's display the contents of index.html. At this point, merge the master changes in the feature1 branch if you wish to retain the feature branch. You have now learned how to merge conflicts and resolve them manually. Let's understand what stashing is. Sometimes it is necessary to revert to the last commit without interrupting the current work. At such instances, git stash comes handy. It records the current state of the working directory and the staging area and reverts to a clean working directory. These stashed snapshots can be queried by using the git stash list command. Any other user can revert to your saved snapshot and continue from the point you stopped. This is done using either the git stash apply or git stash pop command. Both these commands would apply a particular stash state on top of the current working tree. The difference being that when you use the pop command, the stash snapshot is removed from the stash list. Let's understand this through a demonstration. In this demo, you'll learn how to apply a stashed snapshot across branches. This involves creating a snapshot in one branch and applying it at various branches. You are in a particular branch called My Branch. Let's execute Git Status to analyze the status of the files in our branch. Git indicates that file 1 is modified and lists the current status. Here, INC001 and INC002 are fixed, and INC003 is work in progress. While you are working in My Branch, you get interrupted and you have to switch to Master Branch for some work. To switch to the Master Branch, execute Git Checkout Master. Git output displays that you cannot switch since you are in the middle of making some changes, so you are prevented from switching to your branch. There are two choices. You can either commit or stash. At this stage, let's do a stash. Execute Git Stash Save, followed by the stash message. Git confirms the stash. Execute git log one line to identify the version it has rolled back to, followed by git status. Output displays that the working directory is clean. Git indicates that the working directory is clean. Now, if you do the cat of file 1, it doesn't show the WIP status of the INC003. This is because you have just stashed it away and now you have INC001 and INC002. To list down the stashes, execute Git Stash List. Which will show the particular stash snapshot and display the message associated with each stash. These messages added during stashing can help in differentiating the stashes. You can now attempt to switch to master. Let's try it out. Execute Git Checkout Master. The cat of file 1 shows that you no longer have the INC002 or INC003 files you were working on. Execute git log to the list of commits. Let's assume that the task in master branch has been completed and now the work in the My Branch can be resumed. Let's switch to My Branch. Next, execute Git Status. Git indicates that there are no files to commit, but that there is a stash list that needs to be reverted and worked on. So execute Git Stash Apply, followed by displaying the content of that particular file to go back to where you started. Let's apply the same snapshot in the master branch. To make the change in My Branch, execute echo B, finished INC003, done, file 1, followed by git add and git commit. Now the intended changes are completed. Git log would now display all the associated comments. The stash list would display the list of all the stashes because you used apply and not the pop command. The next step is to apply the same stash to the master branch. So in the master branch, the file content displays only INC001. Now let's apply the stash in the master branch. Execute git stash apply. Git indicates a conflict while trying to merge. Now let's resolve this. Execute cat of file1 to check the contents of the file. Git indicates that the files have to be merged manually, as new lines have been added to the file. Before you manually merge, update to get a list of the contents of the stash. The last stash was taken when the status of INC003 was WIP, and that's why it got the part of this particular file. To resolve this, make a few deletions. This was a demo of how you can use the apply command across branches because this was applied at the feature branch called myBranch. How do you get rid of stash snapshot? Execute git stash show, which will display the number of files involved in this stash and the lines updated. Once you are done with applying it everywhere, execute git stash clear. This would clear the stash snapshots. Now you can list the stash to demonstrate that your stash list is cleared and empty. Now that you have understood the concept of stashing in Git, let's see how to rebase in Git. Git facilitates working collaboratively. The feature involved is rebasing. Let's learn about this. Collaboration is essential in a development environment. Sometimes, when you branch off from a commit and start developing your own feature, it is likely that your feature is dependent on a subsequent commit done on another branch. In such cases, you need to get the last commit from another branch. Git rebase is used in such cases. Rebasing refers to the process of moving a branch to a different commit. Let's understand this with the help of an example. Look at the image shown here. You have created a feature branch from commit B on the master branch. There are two commits made on the feature branch, that is commit C and E. In the interim period, there is an additional commit on master called D. Now you are in the feature branch and need the code that was a part of commit D. To do this, execute git rebase master, that is, rebase the current branch to the latest commit in master. As a result, C and E are now based on commit D in the master. Doesn't rebase seem similar to merge? Let's understand the similarities and differences between rebase and merge operations in Git. Both git rebase and git merge are designed to integrate changes across branches. Eventually, they solve the same problem differently. Let's consider a scenario. Let's assume you had 4 commits in the master branch A, B, C, and D. There are 2 users. User 1 creates an additional commit E, and user 2 creates commit F in D. This will result in a conflict that can be resolved either using git merge or git rebase. Let's start with the merge option. Here, you merged the commit E and F into M that inherits the changes from both of them. This can pollute the history and make it confusing for other users to understand. Now let's try the rebase option. Create a commit R, which has the same contents as commit M created during merge. However, once you rebase, F completely vanishes, and its contents are available in commit R. This creates a clean, straight history that can be easily understood by the developers. Note: never use a Git rebase on public branches. Let's see how to rebase in Git through a demonstration. In this demo, the rebasing feature in Git will be explored. You are in the master branch with nothing to commit. There is one file, index.html. These are the two commits in the master branch. Let's see the status of the feature branch. There is nothing to commit here as well. Execute the git log command. Git indicates 4 commits. Let's compare these commits with the commits in the master branch. Commit ID F32AF0F is the parent from which the feature branch has created 2 additional commits. Let's locate this in the GUI tool. There are 2 commits in the master branch, but then this particular master commit is used as a parent where 2 other commits have been made in the branch known as feature 1. Now let's create 1 commit in the master branch and rebase it. Next, open the editor and make changes for a new commit. Once it is modified, execute git add, followed by the git commit command. Execute git log to view the list of commits. Git displays 3 commits. This commit is a step ahead of the commit that is the parent of the feature branches. So if the UI is updated, it shows that although the feature 1 branch has branched off the earlier commit, you have created 1 more commit. Let's rebase the feature 1 branch, which means these 2 commits would be the parent of the commits of the feature branch. Execute the git rebase master command. Since there are no conflicts, Git applies the changes from the feature 1 branch under the latest commit in the master branch. Execute git log. Git displays the list of the commits sequentially. F32AF0F is the parent, and the first 2 commits here in the feature branch, and D50F9A7 were not the parent. The rebasing operation has aligned them sequentially. So the commit history has been modified. Once the UI is updated, the changes get reflected. These 2 feature branch commits have now taken the latest commit in the master branch as the parent. Git facilitates creating a copy of the repository. This is termed as cloning. Let's explore how this is done. You have understood the importance of having a Git repository to execute any operation or function in Git. At times, there can be multiple users within a project who would need to work on the files in the repository. Cloning helps in creating a copy of the repository and links it to the original repository to facilitate working collaboratively. Cloning can be done in two ways. Copy the entire working directory of the original repository. Clone the original repository. The git clone takes two arguments, the URL of the original repo and destination directory. The duplicate repository is synced to the latest changes in the original, making collaboration easy. Let's understand how to create a clone repository through a demonstration. In this demo, you'll learn about the cloning feature in Git. You are in the master branch with nothing to commit. There's one more branch called Feature-1. Currently, master branch is active. Let's switch to Feature-1. Execute git checkout. Because Feature-1 is our current branch, we need a copy of the current directory. Step back to the parent directory and then execute git clone irebase cloned rebase repo. If you look at the directory now, you have a list of repositories you started with. The new repository is created. Let's step back into the repository. The active branch is Feature-1. Why? Git shows the active branch of the cloned repository by default. Notice that git branch did not list master branch. The initial repository from you had cloned had both master and Feature-1 branch. It shows the active branch by default. If you wish to view the other branches, execute git branch -a. Git now displays the master branch. The files and commit history can then be fetched by executing the git log one-line command. Git shows 5 commits in the Feature-1 branch. Now let's move to the repository that was just cloned. You need to run the same command. When you clone, you get the complete commit history. Switch back to the cloned repository. The master branch is now visible, but with the -a flag. Execute git checkout master. The git branch command will now show the master branch. You have learned how to clone with git bash. Now let's learn how cloning is done in GitHub. Let's move to the GitHub repository. As you can see, there are 3 files and 3 commits, followed by a button called Clone or Download. Let's click on the button of the URL used for the clone as shown. Copy it to the clipboard and switch back to git bash. Now execute the clone command using the URL from your clipboard. This way, the GitHub repository gets cloned as a local repository for use. Let's go to our repository, cloned repository, which is the same one in GitHub, and check its contents. This repository has 3 files, and the commit history shows 3 commits, which is similar to the files and the commit history as seen in GitHub. Match the IDs of the commit to confirm. This concludes all the Git operations in this lesson. Let's quickly summarize what we have learned. A branch is a separate workspace, usually created when you need to experiment or test something without impacting the main code base. A Git branch is just a pointer to the commits. It does not change the contents of the repository. A Git branch lets you create, list, switch, and merge branches. The git merge command is used to merge branches in Git. Git stash records the current state of the working directory and the staging area and reverts to a clean working directory. Rebasing refers to the process of moving a branch to a different commit. Cloning helps in creating a copy of the repository and links it to the original repository to facilitate working collaboratively. This concludes all the Git operations. This is the end of the Git course. The next step is to try and practice what you learned. You can download the installation guides and cheat sheets from the Resources tab.